In this video, I'd like to go over how to find trig values using reference angles. Before I do that, I want to go over the two special triangles. The first one is the 45-45-90 triangle, which, if we convert that to radians, the 45 degrees is the same as pi over 4. With triangles, it's good to remember that there's this relationship between the angles and the sides that are opposite. So in this case, since they're both 45 degrees, that tells me that the length of the triangle opposite the 45 degrees, they're going to be the same since the angles are the same. In this case, we're going to write it as 1. If you forget what the hypotenuse is, you can always use the Pythagorean theorem. And the hypotenuse is square root of 2. This is our first special triangle. The other triangle is the 30-60-90 triangle. And if I write that in radians, the 30 degrees is pi over 6, and the 60 degrees is pi over 3. And I know that kind of looks counterintuitive because the 6 goes with the 3. Well, you could use the formula to convert it to radians, but you could also remember that since 30 degrees is the smaller angle, putting the 6 in the denominator makes that fraction smaller, so those go together. And the 60 degrees is the larger angle, and so that goes with the smaller denominator of 3. The lengths on this triangle are 1, square root of 3, and 2. And square root of 3, just write it down, is approximately 1.7. And the reason I write that is if you're not sure where to put the values, again, you can keep in mind that the smallest angle, in this case, is 30 degrees. Across from it goes the smallest side, which is 1. And then the next one is 60 degrees. That's going to be the square root of 3. So I think this is a really good technique to try and help, because what most likely happens is that the 1 and the square root of 3 gets mixed up. And so you can use this technique. Smallest angle goes with the smallest side. The largest angle is 90 degrees, and the largest side here is 2. And you can confirm that this works by using the Pythagorean theorem. Okay, so the idea is that we can use these triangles and the concept of reference angles in order to figure out lots of trig values beyond just 45 degrees, 30 degrees, and 60 degrees. And actually, before I go over that, I also want to talk about the quadrantal angles. The quadrantal angles are the angles on the 90 degrees. So if you look at an axis here, we've got 0 degrees, 90 degrees, 180 degrees, 270 degrees. And then if I keep going, this is 360 degrees. And again, I could convert all of these to radians as well. So we've got pi over 2, pi, 3 pi over 2, and 3 pi. And I realize here I need to update that. So the special triangles above don't really help us with quadrantal angles. And I would say that there's two techniques that you could use. One is that you could actually think about these like triangles, or you could think about it in terms of the unit circle as well. And the unit circle can be used to find these angles above. But if you use the unit circle instead of using these triangles, you only need to know that first quadrant, because everything's repeated after that. You would just need to know whether the x or y's are positive or negative. But in this video, I'm going to show it with triangles. Okay, so here, if we looked at it in terms of triangles, It's a little bit strange, but let's say I try to draw a triangle right here. And the thing is, you need the angle to be right here in the center. So that's kind of my theta there. And so the right angle should always be opposite of that center part. And so in this case, if I think about it, well, what if I want this to be 0 degrees? And if I think about a triangle here, then that would mean I could make the adjacent and the hypotenuse both 1, and then this would be 0. So it's almost like it's just a line there, but I've tried to draw out for just visual representation of this triangle. Then from here, I can use all of the rules for, okay, if it's sine, well, that's opposite over hypotenuse. So that would be 0 over 1. 0 over 1. If it was cosine, cosine is adjacent over hypotenuse, so that would be 1 over 1. So the answer is 1. So that is one way you could get your trig values. And I'm going to also try and do another one. This one's a little harder to see if I drew a triangle up here. Let me not put it on the same axes. Okay, let's try the same thing for the 90 degrees. And I realize, okay, let's try the same thing for 90 degrees. And this is where it can get a little tricky because this has to be the angle right here. And then the 90 degrees is out here. And so now that adjacent value becomes 0, the opposite and the hypotenuse become 1. And then drawing that triangle, again, it's almost like it's a line that's going straight up along that 90 degrees, but I'm sort of trying to pull it out to make it look like a triangle so that I can use those same definitions for opposite, adjacent, and hypotenuse. And on here, I think I want to squeeze in one more. Let me just do the 180 degrees one. So if I draw a triangle out here, so saying this angle is essentially 180 degrees, but if we're looking at it from a reference angle, it's almost like a 0 angle again. 90 degrees goes right out here. The difference is, again, keeping in mind that we're using that traditional XY axis. So where x's are normally positive and negative, same for y's, holds true. So in this case, the height is still 0, just like it was for that 0 angle. Hypotenuse is always positive, so that's a 1, but in this case now my adjacent value becomes -1. So drawing triangles this way is one way to do quadrantal angles, but I actually think that if you use triangles usually, that it's still a little bit easier to think about it more from a unit circle perspective, specifically when you're dealing with angles like 0 degrees, 90 degrees, 180 degrees. So what I typically do instead is I just draw a point on each axis. And so this first point can be represented by 1, 0. And for all of these, the hypotenuse or the r value is equal to 1. And then here we've got 0, 1, -1, 0, and then this is 0, -1. So anytime I'm trying to find the trig value for any quadrantal angles, I'll just write this axis down and then use the definitions here, keeping in mind that x is the same thing as adjacent and y is the same thing as opposite in terms of our definitions.